Okay, guys, following up on the last email, let's try to work with a couple pairs of functions just to practice the skill of doing a composition of functions. Okay? I think maybe at the end, I'll give you a couple of things to play with, a couple of functions to play with, but I may, and I'll provide the answer, but I may not work them out for you just because I don't want the video to run too long. When you're asked to find the domain of a function composition, I'm going to table that for a separate video. But I know that that's going to be the last part of this topic that's going to be a struggle for you guys. Okay? So let's hop in and let's just practice finding a composition of functions. Okay? So let's start with two functions. Already off to a good start. Gonna erase that f, and let's rewrite it as a t. Let f of x equal something simple like 1 minus 4x. And let's let g of x equal something a little more exotic. How about 6x squared minus x plus 2. I don't know what happened there, guys. My iPad just like sneezed. So if the video went weird right there, I'm sorry, but we're going to keep going. Okay. So let us try to evaluate this. I want to evaluate f composed with g of 2. Okay? So the way I would read this out loud, if you'll recall from the previous video, is f following g of 2. So this means we need to evaluate the function g first for my input 2. Okay, so if we want for this video, I'm going to continue to draw the roadmap, but at some point, you may find that you don't have to draw the roadmap, and I hope you reach that point, okay? So instead of going vertically, I'm going to take advantage of this like landscape mode that my video is in, and I'm going to go horizontal instead and see if that gives me a little more room to work with and play with, okay? So my roadmap is going to be, we're going to plug something in to some function. That function is going to have an output, but that output's going to become the input of the second function in my sequence, and then that's going to have a final input. So this time, we want to plug x equals 2 into g first, and whatever comes out of there, we'll plug that into f second. F follows g. Okay. Okay, so as we follow this roadmap along that helps us visualize the path of this input, I'm going to be writing out in blue sort of underneath the steps that we would write out analytically. Okay? So I want to make sure I got the right color pencil. Got it. Okay, go away. So since we're going to be plugging 2 into G, and then whatever that is, we're going to plug that into F. If I reread this left to right, I know I'm going to eventually evaluate F for something. So this is going to equal F of something. All right? What am I going to plug into F? Whatever I determine G of 2 to be. That's going to be my input. Okay? So over here, we plug 2 into G. What does G do to its input? It first it squares its input, multiplies that value by 6, then subtracts that input, and then adds 2. Okay? I don't have room to do all that work right here. So instead, I'm going to keep over here in blue, and I'm going to prepare that way. So I'm going to bring down the F. I know it's going to get evaluated for something at the end, and I'm just going to keep bringing it down so I don't forget. And I am going to prepare in purple here what G does to its input. So G takes 6 times its input after it's been squared minus its input plus 2. So I'm going to close those parentheses. And now I'm ready to receive the input. What value do we input into G? 2. So everywhere I had sort of a port ready and open for my input, I'm going to put that 2. Okay? Now, if you're sitting there watching and like banging your head against the wall and asking yourself, why is this dude waiting to put the input 2 in at the end? It's because I'm preparing us for when my input is something more extravagant than just a single value. This is going to get harder. And if we take this step of preparing for an input, then actually doing the input when the input is something crazier is going to be easier to swallow. Okay, I'm working on it up to something bigger. All right, now I don't want to just take up all of my board space doing order of operations here. So if you guys are willing to trust me, 2 squared is 4. 4 times 6 is 24. 24 minus 2 is 22, and then 22, add that 2 back on, we are back to 24. So this says, once I'm done simplifying, we're going to evaluate f for 24. Okay, if we go to our roadmap, when I plugged 2 into G, when I plugged 2 into this function, what did it output? It output a 24. So what do we have written in blue here on the left? Evaluate f for 24. That's what our roadmap said we were going to do next. We're going to take 24, we're going to plug it into f, and then whatever that output is our final answer. So let's prepare the way. What does f do for its input? It takes 1 minus 4 times its input. So what is my input? My input is 24. And that's just an arithmetic problem after that. 4 times 24 is 96. 1 minus 96 is negative 95. And that's my final answer. F following G of 2 from the beginning, F following G of 2 equals negative 95. Okay? So let's practice one of the things that we learned from the previous video. If I switch this order around and still evaluate it for 2, I'm going to get a different value. Okay? But this time, I'm going to let you guys try it on your own first. But let me get you set up. As promised, I want you guys now to take a stab at evaluating G following f of 2. Okay? You're welcome to take whatever notes, pause, go back, whatever you need to do to feel comfortable. But when you feel like you've got it, I will have the worked out solution prepared for you guys. Okay, so I will see you guys in a moment. Boom. I got 303. All right, really quickly. When I took 2, plugged it into F, I got negative 7, and we can see that work here in purple. Then when I took negative 7 and I plugged it into G, I got 303, and we can see that work here in blue. And I'll be honest, right here, I just plugged that number in my calculator. I didn't try to do 6 times negative 7 squared minus negative 7 plus 2. My calculator did that for me. I don't want to brag, but that's what happened. Okay? Let's do a review thing. Okay? For time's sake, I want us to get to the harder level of problems. But in order to do that, I want to review one quick concept. Okay? So we learned once upon a time that when we evaluate functions, we can evaluate functions for things besides numerical values. So I could ask you, given this function x squared minus 4x plus 3, evaluate something like f of x plus h. So what would we do? We would take that input, x plus h, and we would plug it into the original function everywhere there was an x, those three places. So that would equal, and here's where I was laying the foundation for preparing for an input. What does f do with its input? It squares its input, then subtracts from that 4 times the input, then adds 3. So I'm going to get ready. My input's going to go here. I'm going to square it. Minus 4 times my input plus 3. So what is my input? My input is this x plus h there, and x plus h there. So then we simplify. And remember, simplify just means get rid of parentheses, then combine any like terms. And then if there's fractions involved, also worry about not clearing fractions, but simplifying our fraction by canceling any common factors. Okay? So how do I square x plus h? I'm going to have to FOIL that out. How do I get rid of these parentheses? I'm going to have to distribute this -4. We've already covered these in other videos, so I'm just going to fast forward to the part where we've already FOILed out. When I multiply x plus h times x plus h, I got x squared plus 2xh. Forgot my h. Plus h squared. That's all from FOILing. Then I'm going to distribute that -4. So minus 4x minus 4h, and then bring down that plus 3. I'm going to look for any like terms that I can combine. And I honestly don't think there's going to be any, but I'm going to check anyway. I've got a regular x squared here. I look to the right. No x squareds, no x squareds, no other x squareds. I have xh's here, looking to the right. No other terms that have x and h. H squareds, no other h squareds. X's, no other regular x's, h's, and boom, no other constant terms. Okay, so this ended up being my simplified answer. But what I wanted to point out, again, the important part of this review was I can evaluate functions for things that aren't strictly numerical, including other functions of x. Okay? Here's how we're going to use it. Let's go back to f of x equals 1 minus 4x and g of x equals 6x squared minus x plus 2. And this time, what if I wanted to evaluate, hang on, I'm playing with something behind the curtains here. What if I wanted to evaluate, oh wait, really sorry for that interruption. And I've totally lost the train of thought of wherever I was. I had pushed a button incorrectly, and I had to pause the recording to figure out what was going on. So now I'm just going to start over. I have these two functions. This time, let's evaluate. I got this. Let's evaluate. Now it's working. F following g of. Previously, we'd plugged in 2. This time, let's just plug in arbitrary x. Okay? So, my roadmap. I'm going to plug something into one function first, and then the output for that's going to become the input for the other function. So, what is my input? Oops, I forgot. According to the way we've written this, we're doing f following g, so we're going to plug something into g first. And then f. So what is my input this time? My input is just arbitrary x. Okay, analytically, if I write this down, since f is going to follow g, we're eventually going to do f evaluated for something, but I'm going to get it ready. What am I going to plug into f? I'm going to plug this into f, whatever g of x is. So that is g of my input x. Okay, over here on the roadmap. If I plug x into g, what am I going to get back? I'm going to get back g of x, whatever g of x is. So this is f of what? What is g of x? G of x is 6x squared minus x plus 2. That's what we're going to plug into f. And that's an overwhelming bit of information for our eyeballs to digest at once. Okay? So, there's nothing I can do to simplify g of x. There's no like terms to combine, any parentheses to get rid of, or anything like that. It came to me already simplified. This thing in purple is what I'm going to plug into f. So what does f do? It takes 1 minus 4 times its input. So let me get that ready. 1 minus 4 times its input. But what is the input? The input is this g of x in purple. 6x squared minus x plus 2. And then we simplify. What does simplify mean? We get rid of parentheses and then we combine like terms. So the only pair of parentheses I have are right here. So I'm going to have to distribute my negative 4. And then I'll look at combining like terms. So this is 1 minus 4 times 6 is 24, x squared. Negative 4 times negative x is positive 4x plus 4x. And then negative 4 times positive 2 is negative 8. And the only like terms I have to combine are my constant terms. So I'm going to move that 1 over there with the minus 8 at the end. Negative 24 x squared plus 4x. 1 minus 8 is negative 7. And believe it or not, that's my answer. What is f following g of x? It's equivalent to negative 24x squared plus 4x minus 7, as gross as that is. Up here on my roadmap, when I plugged g of x into f, what did I get? I got f of g of x, which is equivalent to the green box down there. Okay, let's turn it around for practice sake, and we're going to get a different looking function. But I'm going to do it together with you guys. Okie doke. This time, let's do g following f of arbitrary x. Okay? So we're going to evaluate g for something eventually. But what am I going to evaluate it for? I'm going to evaluate it for whatever f of x is. That's my initial input. So let's get it ready. What does g do? Oh, wrong color. What does g do? It takes 6 times the square of its input minus its input plus 2. So let me get that prepared. No, I'm sorry. I skipped a step. First thing I'm going to do is I'm going to rewrite f of x with what f of x equals. I'm going to replace this with this 1 minus 4x. So this is g, eventually going to be evaluated for 1 minus 4x. Okay, now let's get g ready. G takes 6 times its input after it's been squared, minuses its input, plus 2. So we've created space for our input. So everywhere I need that input, I'm going to plug in that 1 minus 4x, 1 minus 4x. And then we've got to simplify. Simplify means get rid of parentheses first. So here, I'm going to have to square that. But because there is subtraction inside, I'm going to have to FOIL that out. We're going to do it together. And then over here, I'm going to have to distribute that negative to get rid of those parentheses. But let's start with that foiling. And I'm going to go off to the side, scratch work. Maybe you've done this so many times by now that it's second nature, but we're going to do it together. I felt a Bob Ross moment there, like I was telling you about painting some happy trees. Okay. First term times first term, 1 times 1 is 1. 1 times the minus 4x is minus 4x. This minus 4x times that 1 is also going to be minus 4x. And negative 4x times negative 4x, negative times negative is positive. 4 times 4 is 16. X times x is x squared. I have 2 like terms in the middle. So clean up 1 minus negative 4x's minus 4 more x's is minus 8x's plus 16x squared. So that's as simplified as I can make that. So I'm going to take this and replace it back here. So we have 6 times, I'll write it in red, 1 minus 8x plus 16x squared. Whew, that was fun. Next up, let's distribute that negative like we said we would do. That's just going to change my signs. So I'm going to get minus 1 plus 4x. And then that plus 2 at the end. I still have some parentheses to get rid of. I still have to distribute that 6 to the 3 terms inside. So this is going to equal 6 times 1 is 6. Minus 6 times negative 8x is minus 48x. Plus 6 times 16 is 96x squared, minus the 1, plus the 4x, plus the 2. We got rid of parentheses. Let's combine like terms. For no reason other than I'm just a classically trained person, I'm going to start with my x squareds and then work my way down. So I've got x squareds here. Do I have any other x squareds? No. So I start with my 96x squareds. Then I look for my x terms. I've got minus 48x is there, plus 4x is there. Negative 48 plus 4 is negative 44. You'll check me on that. I'm not feeling perfectly confident on that. Yeah, I feel good now. Okay. And then I combine my constants. 6 minus 1 is 5. 5 plus 2 is 7. So bada bing, plus 7. And that is what g following f of x is. Okay? Now, again, for time's sake, I'm not going to go back and prove this to you, but if you were to evaluate this function for 2, I bet you would get 303 like we did on the second example. And if you go back to the slide before, which I've already forgotten what we got, and you evaluated that for 2, I bet you would have gotten negative 95 like we did on the first example. Okay? It's not a big deal, but it should be true all the same. Okay? So, for the end of this video, let me give you 2 new functions, and I'm going to have you practice evaluating, no, that's not what I want. I'm going to have you practice evaluating f following g of a number and f following g of x. Then, like we have here, g following f of a number and then g following f of x. And then I'll provide the answers, and hopefully you give yourself a high five because your answers match with mine. All right, see you on the next slide. Okay, so we're going to try the bicycle without the training wheels. Let's let f of x equal x squared plus 5x plus 2, and let's let g of x equal x plus 4. Let's make an attempt to evaluate f following g of negative 1, then g following f of negative 1, then f following g of arbitrary x, and then g following f of arbitrary x. Okay? So, when you're ready to go, hit pause, get to work, and when you come back, I will have my answers ready. Voila! I got that f following g of negative 1 equals 26. I got g following f of negative 1 equals 2. I got f following g of arbitrary x is x squared plus 13x plus 38. And I got g following f of arbitrary x equals x squared plus 5x plus 6. If you got any of those right, give yourself a high five. If you got all 4 right, call your mother and tell her that you love her. I wasn't planning on doing this, but I am going to go ahead and work through these bottom 2 together with you, just in case you got them wrong. But if you got everything right, or if you're just tired of the sound of my voice, you're welcome to stop listening at any point. Okay? So I'm willing to bet, I believe in you, that if you go back and if you miss one of these, you'll be able to find your mistake. But these can be a little more daunting. So I am going to work through these 2, and if you're sticking around, see you there. Okay, f following g of x is f evaluated for g of x. So that means I'm going to plug g of x equaling x plus 4 into f. What does f do? It squares its input. Then it multiplies 5 times that input. And then it adds 2. So my input in this case is x plus 4. There and there. And I am going to skip this step. I'm going to fast forward to the part where we've FOILed this out. And I'm going to tell you we get x squared plus 8x plus 16. That might have been your mistake right there. If you didn't get what I got previously, here I'm going to distribute my 5 and get 5x plus 20 plus that 2. I'm going to combine my like terms. I have just the 1x squared. But then I have 8x's plus 5x's here, which is plus 13x. And then I have 16 plus 20 is 36. 36 plus 2 is plus 38. All right. Next page. G following f of x is g evaluated for whatever f of x is. So that's g evaluated for f of x was x squared plus 5x plus 2. So that's what we're plugging into g. What does g do? G has a much simpler function. It simply takes its input and adds 4 to it. So what are we plugging in? We're plugging in x squared plus 5x plus 2. And these parentheses that I have that I need to get rid of aren't really doing anything. There's no number out front to distribute. There's no exponent up here to worry about. So I can go straight to the combining like terms step. And the only like terms that I have are the constant plus 2 plus 4. And so we get x squared plus 5x, 2 plus 4 is 6. Finally, that's the ball game, guys.